Hello everyone, these are the authors of the work entitled Promoting a Dispersed Urban Mobility Approach for Rehabilitation of Historic Cairo, Dr. Du'aet Salah and Dr. Wala Salah. This study puts forward a research question whether promoting a dispersed urban mobility approach would present a sustainable rehabilitation scenario for urban heritage. This research aim was studied for the Historical Center of Cairo, declared a World Heritage Site by the UNESCO. The rehabilitation plan proposed by the United Nations Development focused on Almaz Street, which is the main spine extending north-south the Fatimid capital. It's noted that there is a rich network of cultural heritage buildings and urban spaces located beyond the touristic route, but unfortunately they are paid less attention. A previous study divided Almaz Street into 9 sectors for rehabilitation, based on the contribution of Sabil buildings as a new sustainable urban nuclei. The study explores the hidden routes in the urban microscale through investigating 3 proposed routes of different distances to promote dispersed mobility beyond Almaz Street. The slide shows a variety of monuments and heritage buildings located in the studied sector. The analysis, according to literature review of previous researchers, has investigated spatial studies through 2 categories of analysis. The former, which is the urban analysis, aims at investigating visual exposure to cultural heritage buildings. Hence, an isovist or viewshed analysis investigated the area in a spatial environment directly visible from a location within the space. While on the other hand, environmental analysis aims at investigating the environmental quality and carbon emissions of the space defined. The former includes criteria related to achieving outdoor thermal comfort conditions and others. The isovist field analysis is a component supported in Grasshopper software, aiming to compute an isovist sampling at a certain location. It's used in the study to enable studying the visible urban fabric within a sequence of test points along each path. While on the other hand, the Ladybug view analysis investigates the average percentage of visibility to the hidden cultural heritage buildings in relation to each path. And here, the solar radiation analysis, you can hear, differs from one route to another. Route A, B, and C depends on the distance and area and the amount of exposure of each route to the solar radiation. And also the carbon emission analysis was based on observation and field analysis for the 3 routes, and they were computed according to the number of vehicles passing through each route per annual or per year. And here they were, the result shows that the isovist field analysis using Ladybug Grasshopper shows that route C includes 2 test points and an isovist area of 5071 meters squared, while the view analysis using also the same software shows an average percentage of visibility of 2.2, which is the highest among the other routes. The solar radiation analysis, on the other hand, shows that route A proposes moderate, mostly no skin harm due to long exposure periods to solar radiation. The CO2 emissions, on the other hand, also shows that route A contributes the least to CO2 emissions. Finally, putting all these, the 4 parameters together and based on equal pointing of parameters, this shows that route A has the best or the optimal contribution in terms of promoting a dispersed urban mobility approach compared to the other 2 routes. So, finally, the study recommends adopting a sustainable approach to promoting a dispersed urban mobility rehabilitation scenario in historic cities, taking a case study of Old Cairo. This study can be replicated for the entire historic quarter of Old Cairo as well as for other old city centers. Thank you very much. I hope you have enjoyed this presentation, and now any questions? Thank you.